It really does help. Okay, so integration using long division. Occasionally, we might be asked to integrate a rational expression whose numerator's degree is either greater than or equal to its denominator's degree. So go ahead and use your highlighter. So whenever the degree of the numerator is equal to or greater than the denominator's degree, we can use the technique of long division. So watch what I'm going to do here, because if I tried to do a u substitution, if you try to let the numerator be my u, I can't have the u in a denominator, okay? Then I'm stuck. So the technique of polynomial long division helps. So watch what we're going to do. We're going to do the division. And we're going to rewrite this into an equivalent form. So I'm going to pause a moment, and I want you to try to do the polynomial long division. Unfortunately, polynomial long division lends itself to lots of mistakes, okay? So try to be careful. All right, so I'm getting 3x plus a remainder of negative 10x plus 5 over x squared plus 4. Are you getting that? So watch what I'm going to do. I'm going to rewrite this as 3x plus negative 10x plus 5 over x squared plus 4 dx. I cannot do a u substitution with that rational expression because of the plus 5. Okay, I would have a problem. So I'm going to also show you another technique. We've used it, but not at this level. So watch what I'm going to do. I'm going to rewrite this. Using my sum property. And I want you to jot it down, and then I want you to look at it and think. Think about what I've actually demonstrated here. The key part is what I have right here. Do you see that this is equivalent to the line above? That if I have negative 10x over a common denominator plus 5 over the common denominator, that is in fact negative 10x plus 5 over the common denominator. I am allowed to do that as basic fractions. So now I'm going to treat these as 3 separate integrals. We know how to do this one, and I'm going to get 3x squared over 2. Now, all 3 of these would have an arbitrary constant c, but it would be c1, c2, c3. When I'm done, it's c4. We're just going to, when we're done, call it c, okay? But technically, there is a c with every single one. Now, with this piece, I can do the u substitution of x squared plus 4. du is 2x dx. So I'm going to pull the negative 10 out and the 1/2. and that'll be 1 over u du. Plus, now in this one, I can pull the 5 out. And are you recognizing that this is my arctan? Yeah, this is the u squared plus a squared. So here we go. This is 3x squared over 2 minus 5 natural log. And can we just jump to putting x squared plus 4 back in? Then this one would be arctan x over 2. And then there's my arbitrary constant c. So pretty tough. Okay, this is a pretty tough one. So do you see I used 3 different techniques in this, really 4 if I consider the long division first. Now 6.10 is not on the quiz Thursday. Okay, this is not on the quiz Thursday, but it will be on our chapter 6 test, which is next Thursday and Friday. All right, in letter B, the degree of the numerator is higher than the degree of the denominator, so that indicates polynomial long division to rewrite. So go ahead and start this one. Try and rewrite it and see how far you can get before I start working it out. Thursday, I have office hours. Unfortunately, that'll be after the quiz. But if you are struggling with some of these concepts, I'll be available in the morning tomorrow and Thursday morning. I feel like a broken record, but I strongly recommend forming study groups. We have now hit some very, very challenging concepts, and study groups would be really helpful. All right, so this rewrites as x plus 3 plus 3x plus 4 over the divisor. So I'm going to rewrite this. All right, see if you can look at part A to guide you through the integration. You understand why I can't just put this one 3x plus 4 over x squared plus 5? If I try to do u is x squared plus 5, du is 2x. And then I'd have a problem with the plus 4. Like that's why it doesn't work as a u substitution standing alone with that rational expression. Okay, now in this last one, do you see this really is the arctan? I've got u is x. And then if a squared is 5, a is the square root of 5. Okay, so be careful with this. Oh, whoops, did I forget my 2 up here? I did, sorry. Because that's over 1 over a. Sorry, go back up to part A. That was 5 over 2. Remember, arctan is 1 over a. Arctan u over a. Sorry. There we go. Okay, that's a tough one. So the integral of du over a squared plus u squared is 1 over a arctan u over a plus c. This is what we put on our yellow sheets. All right, questions. So this is getting really comfortable with your different integration rules and techniques. So this will definitely be a lesson that you want to look back through. Say, okay, now what did we do? How did we do that? Why did we do that? All right, so here's completing the square. So this is why I had you do this one. So when I look at example 2, and it says find the integral of dx over x squared minus 4x plus 7. All right, there's no long division for me to do. And I don't have a u substitution that I can do. So watch this. If I complete the square, I would take half of negative 4, which is negative 2, and I would square it. So this becomes the integral dx over x minus 2 squared plus 3. So do you see I have now created the arctan integral where I have allowed u to be x minus 2, so du is dx. A squared is 3, so a is the square root of 3. So this is 1 over a arctan u over a plus my arbitrary constant c. Let's look at another one, and I'm going to write this one up for you to jog your memory. So if you can't get it of the form integral du over u squared plus a squared, we want to take a look at one of our other inverse trig integrals. So if I look at example 3 and I want to find the integral of 1 over the square root of 3x minus x squared dx, where the leading coefficient is negative. So watch what I'm going to do. I'm going to do a little manipulation here. This is a lot of algebra. So my experience teaching AP Calculus is that students don't have as much difficulty with calculus as they do with algebra skills. We tend to struggle with some of these algebra skills. Do you understand why did I make this negative 3x when it was positive 3x in the line above? Yeah.
Because the first sign equation requires the minus u squared to be negative.
That's true. And then do you also see that I pulled the negative out? So a negative times a negative, it truly is equivalent. But you're absolutely right. I'm going for this formula. So then watch this. Okay, this is where it's going to get really tricky. I need to take half of negative 3, which is 3 halves, and square it. So inside the parenthesis, I'm going to add 9/4. So I took half of negative 3. So, and this would be no calculator. This would be a no calculator. We've got to practice our fractions. And negative 3 halves squared is positive 9/4. But there's a negative in front of that, so I've technically subtracted 9/4. So what I'm going to have to do is to counter that by adding 9/4. Let me go over that one more time. This is really tricky. So I think we understand where the 9/4 came from, but technically I have subtracted 9/4. So I have to counter that by adding the 9/4. So I'm going to now flip this around and call it 9/4 minus x minus 3 halves the quantity squared dx. So now I've put it in my arcsine formula. So u is x minus 3 halves, so du is dx, so I don't have any multiples to worry about. A squared is 9/4, so a is 3 halves. So I think we're ready to go. This will be arcsine x minus 3 halves over 3 halves plus c. I seriously doubt that would be a final answer in a multiple choice. This would definitely be a multiple choice style question. So can you see that this piece, the 3 halves, would cancel to make it 1? And what happens when you take x divided by 3 halves? It's a reciprocal, right? So let's just tidy that one up, because that's not going to be how you're going to see it. You're going to see 2/3 x minus 1. And I want you to know in this lesson, we've gone up, this is the highest level, okay, of integration. We're up at the tippy top here. The good news is on Friday, 6:14, is nothing new. We are going to press pause, and I'm going to throw all sorts of integrals at you, and you have to decide which technique do you use, okay? All right, so here's the last type. Integration by adding 0 to the numerator. And again, I don't know how you would, as a calculus student, come up with this, but now that I'm going to show you, it goes in your math tool belts, okay? So it's one that, honestly, I don't know how you would think of this, but once I show you, you'll go, oh, okay. So this one does sound a little strange. How does adding 0 to the numerator help us find an antiderivative? While it may be viewed as a bit of a trick, this method provides an easy way to transform the integrand to something more manageable and therefore integrable. Fortunately, it is not likely that you will see this type, thank goodness, on the AP exam. This is probably more of a BC, but let's go ahead and take a look at it because it's super cool. So watch this. What if I add and subtract e to the x? So do you understand I've added 0, correct? Now watch this. This is like going to blow your minds. Watch what I'm going to do here. And so sometimes the mathematics is just incredibly cool. Again, I wouldn't think you would think to do this, but it is like unbelievably cool. So watch this. I'm going to change colors here. What happens to my first fraction? It's 1, right? 1 plus e to the x over e to the x plus 1, that's just 1 dx. We know how to do that. And what could you do now with the second fraction? Yes, how? How? What would I want to substitute? You got it. Watch that. So then I'm going to have, that is 1 over u du. So that's x minus the natural log of, and isn't e to the x always positive? Yeah, if you think about what the graph of e to the x looks like, that's always positive. So there's my final answer. That rocks. That was like super cool. Okay. So let's do the last one. It says find the integral of 2x minus 1 over x squared minus 2x plus 3. And again, I don't know how you would know to do this, but now I'm going to show you. So I'm going to subtract 1 and add 1, and then watch this. This is like, oh, cool. Cool business. So this is going to create 2x minus 2 plus 1. Can anybody see where I'm headed? Yes. Okay, good. Good, good, good. Okay, so watch this. I'm going to split this as 2x minus 2 over x squared minus 2x plus 3. So now, in my first fraction, you should be able to recognize that the numerator is the derivative of the denominator. Okay, so I'm going to do a u substitution. On this one, okay, I can't do a u substitution, but what technique did we just learn that maybe I could manipulate here? Completing the square. Nice, nice. Okay, so I'm going to pause and give you a head start. Try and finish this one before I do. Yay. So while you're working, tonight's homework is the 610 worksheet. Tomorrow we do have shortened periods, and we're going to spend the period just reviewing. So the review sheet is not very long. So I have on this wall our 5 kind of station problems. Some of them do the entire unit. And then I did put my worked out key is on that table there, the white packet. So if you want to take pictures of it, work it, that's absolutely fine. Those of you that were absent, those around the room problems were outstanding practice. It did spell lumberjacks. It is so funny. My other period said slumberjack too. I'm like, that's not a word. But it made me giggle. I was like, that's good. Oh, yesterday's Wordle was tough. I mean, I did end up getting it on the 3rd try, but like, I don't know about you, but I sit with a piece of paper and like try things. I don't know if that's what I'm supposed to do, but I almost didn't get it. I was like, oh my gosh, that was really hard. And then I didn't realize it could repeat a letter. And then I was like, oh, I don't know all the rules yet. All right, did we get this one? Natural log, absolute value, x squared minus 2x plus 3 plus. I have to complete the square on the one on the right. Be careful with that one because a squared is 2, so a is the square root of 2. And so that formula is 1 over a.